Hi everyone, Mrs. Basega here, and today we're introducing forces. First off, a force is an interaction between two objects. You might have heard it written as a force is a push or a pull. Over here in parentheses next to the F symbol for forces, you'll see that forces are measured in a unit called newtons. In American units, we might call them pounds, but things that are not force units would be things like grams or kilograms. Those are actually something else. Forces are measured in newtons. Forces are also an interaction between two objects that could, depending on their balance, change the motion of those objects. In this case, I have a lot of force being applied to this gentleman right here, but we don't have any change in motion because the forces are balanced. The forces may or may not cause motion. Overall, there are many types of forces that you and I apparently experience. But that doesn't mean that's really what's there. One of the big takeaways for today is that the forces that are there are largely coming from one of these four. In this case, we know gravity, and we'll work on the other ones for now. Here's one that you need to write in your notes. Number 1, the gravitational force. The gravitational force is an attractive force between any two objects with mass. Yes, you're gravitationally attracted to the Earth, but to be fair, you're also gravitationally attracted to your car, or your English book, or a pencil. You're just more attracted to objects that are more massive. So if you were on a more massive planet, you would have a greater gravitational force. Its symbol is Fg, or weight, W. Either case, those two are synonymous with each other, and the direction is always straight down towards the center of the planet. The weak nuclear force is another one of the four fundamental forces. However, this is not one you need to write for your notes. The ones you need to write for your notes will have a little number on the side. You don't need to put this one into your notes because you and I never ever will experience the weak nuclear force. We don't even have uses for the weak nuclear force. This is the force that holds protons and neutrons together. In this case, protons are actually up and down quarks that are held together by this weak nuclear force, whereas neutrons are one up and two down quarks held together. The force that you and I experience most often, but don't always notice, is the electromagnetic force. This force encompasses a huge number of apparent forces that actually just come from the fact that positive charges attract negative charges and vice versa. Here's an apparent force that you absolutely have to write down. This is your second physics force of mechanics. It is tension. Tension is a contact force. It's a force that occurs where there's a rope or cable or string that pulls on an object. And you might be thinking to yourself, Ms. Basega, how is that an electric force? Well, it's an electric force because the electrons cause bonding between the atoms to form molecules. Those molecules make up the threads of this string. Tension is always in the same direction that the string is pulling. So in this case, there is a force on the person's right hand to the right by the string. The third force you absolutely need to write down is the normal force. It's also called the support force. Its symbol is Fn, and this is the force that prevents two solid objects from going through each other. This is the force that's preventing you from falling through your chair, or this book from falling through the table here. The direction is always perpendicular to a surface, and it occurs whenever two surfaces are pushing against one another. As you're sitting in your chair right now, the chair is holding you up because of the normal force. But ultimately, the normal force is really just electricity in disguise. It's the electrons in your butt are repelling the electrons in the chair, so technically you are floating above your chair, just in such a small distance that you don't see it. The fourth force is the force of air resistance, or drag. Its symbol is Fd for drag, or FAIR for air resistance. Up to you, doesn't matter what you call it, I'll know what you mean. And this is the force of motion that prevents you from moving through any fluid. Now, a fluid could be a liquid or gas. So in this case, the parachuter falling through the air is prevented from moving because of the fluid, the gas, the air, preventing them. The direction is opposite the direction of velocity. So if the person is falling down, the air resistance is up. But when a spaceship launches off the ground and it's traveling up, air resistance is down. It's opposite the direction you're moving. And perhaps that is why people confuse air resistance and friction. Friction also acts in the direction opposite motion. However, it's not the same. Whereas air resistance was a solid moving through a fluid, this is two solids rubbing against each other. Whereas air resistance, you absolutely needed to be moving. You sitting there in your chair or in your bed or at your couch has no air resistance. Friction, you don't have to be moving. When our buddy down here in the picture pushes on the fridge, if the fridge doesn't move, that's because the friction force prevents it from moving. This occurs whenever you have two objects sliding past one another or attempting to slide past one another. And the last one is the applied force, Fa. The last one you need to know for mechanics is the applied force, and this is a force exerted by a human or animal. This would occur when you have a human or animal that is trying to apply a force, like you closing the refrigerator, or this wolf biting this watermelon. The applied force of the bite, right? It actually comes from the electric force. The electrons in the wolf's teeth are repelling and pushing apart the electrons in the watermelon. So it turns out lots and lots of forces come from electricity. Other electromagnetic forces include lift, thrust, buoyant force, magnetism itself. Some of those we'll hit on later this year, some of those we won't. But in any case, big idea is lots of forces are actually just electromagnetism in disguise. The last of our four fundamental forces is the strong nuclear force. We actually do experience this one relatively regularly. This is the force that holds nuclei together. The protons and neutrons themselves should be repelling each other out of the nucleus, but they are not. That's because the strong nuclear force holds protons and neutrons together in the nucleus. This force is stronger than electricity. The strong nuclear force is the strongest of the four fundamental forces. So in order, the four fundamental forces are the weakest starting with gravity, then weak nuclear force, electricity, magnetism, and nuclear. Strong nuclear, that is. When you split an atom and it releases tons and tons and tons of energy, that's because the strong nuclear force is strong. All right, that being said, I think that is all we need in order to play the next game. So let us go play that. Best of luck!